Hello again. Just a quick fix in my previous lecture, in the previous video. There's a little mistake that I did, not a mistake, but I couldn't explain probably good while I was recording. So that's why we need lots of people in my Discord server so that you can fix me sometimes. I do silly mistakes as well. So here we said that we have a minus and then we move the minus inside the sign. And I said that you can prove it. Well, of course you can prove it. And I actually proved it on the screen, but I didn't realize it at that moment. Well, sorry, I think I was like a little bit too focused on the recording. So this is how it works. So in your argon diagram, as we said, let's say that you're looking for the sign. Looking for the sign means, well, this is your cosine and this is your sine, right? Sorry, not in argon diagram, in your xy coordinate, in your unit circle, let's say your y coordinate is your sine. Okay, so if I make an angle between 0 and 2 pi, sorry, between 0 and pi, okay, let's say on this line, so 0 to pi is here. If I choose any angle, okay, let's say this one, okay, this angle, or I don't know, something less or something more, then the value will be positive for sine, right, in all cases. Right? But if I do the same thing with the negative of that angle, so let's say that I go backwards, negative of that angle means going backwards in the unit circle. So I go here and then I choose this, okay, and this value will be the same value as this one, but the negative sign, right? Because you have then reflection on the x-axis. So if it's minus 0.5, let's say, so plus 0.5, this will be minus 0.5. So indeed, if your angle is between 0 and 2 pi, 0 and pi, you can do this. So minus sine of theta will be equal to plus sine of theta, minus theta, of course. Okay. For the following reason, as we said, between 0 and pi, you have all the time the positive sign. And if you go to the bottom side of the unit circle or this xy coordinate, then you have the sign all the time negative. So in both cases, negative times positive or positive times negative will give you the same value, right? Because the value in absolute value will be the same, 0.5, but the sign will change based on if you go plus or minus angle, so either clockwise or anti-clockwise, but then this small minus and the small positive in front of the sign will change it back to whatever you need. Okay, in this case minus times positive will be minus, in this case positive times minus angle minus value, let's say, will be equal to again negative. Okay, so at the end the sign matches. Well, can we do it for all the sign values? So let's see. I don't know. I don't really remember the whole details, but let's see. So if I choose an angle more than 2 pi, let's say, more than pi, can I do negative of this? I think I can do it. So so this is my, let's say, the more than pi. So then I choose the negative of this angle, which means I do go backwards. I reach here. Well, yeah. Again, you are symmetrical, so this actually works for all the angles between 0 and 2 pi. Yes, I think it works for the angles from 0 to 2 pi, so there is no problem with it. Okay, also, when we change this angle, we also have to change pi divided by 2, right? So let me now delete the screen. So now you change it back to, let's say, so you have, root 8 times cosine pi divided by 2. Now we made it plus sine of minus pi divided by 2. This is still not a polar form, right? Because the angles are different. But cosine pi divided by 2 will be equal to the cosine minus pi divided by 2 by the same logic. So let's go back to the unit circle. Okay, so now we have the cosine here, the sine here. If I go some angle between 0 and pi, let's say for now, so this is the angle, okay, and then I go it backwards, let's say, okay, so which means I will use another color. So I go the same angle backwards, and this is the value that I need, this one, and this one for the sine. But what will be the cosine? If you are looking for the cosine, then that means I need to look at the x-coordinate, which is this point here. So as you can see, making this pi divided by 2 minus or positive doesn't change the fact about the value of the cosine for the angles between 0 and pi. These probably will work for the all the angles. Let's check it out. So if I go more than pi, so let's say this is my cosine. I'm looking for the cosine of this angle. So let's say that I choose now the negative of the same angle. So which means I go anti-clockwise until I reach this. Okay, I reached it. So what will be the cosine of this? Again, since we are looking for the same for the x coordinate, this will be the value for both of them, and you have a reflection on the x coordinate. Well, as you can see, this works for the all the angles between 0 and 2 pi. Okay, so which means you can just simply write cosine minus pi divided by 2 here. So root 8 cosine minus pi divided by 2, okay, plus sine minus pi divided by 2. Okay, so here's a little proof and a little tip for you for the cosine and sine to have negative angles inside. Okay, I'm not sure if it's one of the rules in IB. That's what I was meaning. I think I'm not sure if I can exempt it. Oh, there you go. Maybe I can do this. Maybe it's written here. I didn't read it. Okay. Okay. They just say that you will need to convert it to the correct form first. Well, thanks. Of course, I need to convert to the correct form first. But as you can see, you can move the negative sign inside. You can make the angle negative or positive based on the rules I just explained about the sine and cosine. For cosine, it doesn't matter. You can just simply change the sign inside the cosine, right? The sign of the angle. And you don't have to change the sign of the cosine itself. But for the sine, you do have to change the sign of the sine functions as well. Again, which means that if you have sine theta, then this will be equal to minus sine of minus theta. Yes, which is true. Let's say again. So I got this here, minus theta. Yes, correct, exactly. Or the backwards. You could have a sine of minus theta. That will be equal to now minus sine of theta. Okay. So that's the same thing. And that's all. That's all. These two rules are important, and we have seen the proofs. I just wanted to fix it. Everything else in the lecture is probably 99%, 100% right, I think. But I just wanted to give you a little proof and the tip on this. Okay. And again, thank you very much, and sorry for the additional fix video. Again, that's why we need more people in my Discord server, so that you can ask me your questions, fix me, and have a very nice community where we can work on the IB and the mathematics all together. Okay, perfect. See you soon, and don't forget to subscribe and put a like button.